I reckon you'd be able to follow really easily if I said, okay, I don't want to rotate it around the x-axis, I want to rotate this function around the y-axis. So if I was rotating it around the y-axis, we put up our axes here, and we'll use something that approximates the same function, looking like that. But now we want to rotate it around the y-axis, so it's going to look a little bit like that, and then it'll look a lot like. And if I wanted to rotate this around the y-axis, then the volume is actually going to be pi times, and again we'll say that the limits are from A up to B, because that takes us out to there, that's the radius. The integration from A to B of function f of y squared dy, because now the height, the size or the length of this, this shape that we're getting, this volume of rotation, is to do with the y-axis. So if we're trying to get a volume of rotation around the x-axis, it's a function of x squared with respect to x. If we're trying to rotate something around the y-axis, it's a function of y squared with respect to y. And we just have to have the limits of integration. Now, I'm going to give an example from an exercise, exercise 3.9, I think it is. Again, I'm going to have to dig into the book and bring that on screen. But the principles for what you do for rotations around the x-axis and rotations around the y-axis are identical. They're absolutely identical. You just need to make sure that here we have a function of x under the integration sign that's squared. Don't forget that squared. That's what a lot of students will do. They'll forget that squared sign. When it's here, we're going to have a function of y that's squared. Okay, so let's have a look at a question. I'm just going to pick one out. It doesn't matter which one, so I'll just jump straight into, say, question. Okay, we'll do question 5. So it's exercise 3.9, question 5. X equals y squared minus 5 is rotated around the x-axis between 0 and 3. So from x equals 0 to x equals 3. Okay, so what's this look like? It's a parabola. It's a parabola, and it's parabolic in shape, and it's a parabola that's not y equals x squared, but x equals y squared. So it's a parabola that's tilting on its side. It's going to look something like this. It's got a positive coefficient, so it's concave to the right, and it's got a minus 5 here, so that the constant term is outside of the working part of the function, which means that the whole parabola gets shifted to the left, like this. Alright, that's what the function would look like, x equals y squared minus 5. Okay, and we have to do it from x equals 0. Well, the line x equals 0 is aka the y-axis, up to x equals 3. So we're doing it from here to there, and it's this bit, if you like, it's this bit here that's going to be rotated, and we'll be finding the volume of that shape about the x-axis. Now, do you remember I said that if we're trying to rotate something around the x-axis, if it's rotated around the x-axis, we've got to have a function of x, not a function of y, but a function of x. At the moment, this is x is a function of y. So we're going to have to massage this little fella so that it becomes y equals a function of x. I hope you're following me. At the moment, x is a function of y. We have to change that so that y is a function of x, which is not too hard. We just make y the subject of the formula. That's what we're doing, really. And that is like year 8 stuff, year 8, year 9 stuff. Well, not year 9 for you guys because you're all odd, but for most people, that's year 8 or year 9 stuff. We make y the subject of the formula. So if x equals y squared minus 5, then x plus 5 is equal to y squared, which means y is equal to, well, technically it's plus or minus the square root of x plus 5, but we're really only interested in the upper part because we deal with functions, and in order to have a function, it's got to pass the vertical line test. And that means it's only this bit. It's not actually that bit there that is a part of the function. That would make it a relation, not a function. Now, that part of the curve there, it's just a function. So now we have y and we've got a function of x. And the integration is really simple. They've given us the limits for the integration. It's from 0 to 3. And the thing's going to look a little bit like that. That's what it will look like. Let's just do the integration. So the volume is equal to pi outside of the integral from 0 to 3, of the function of x, which is x plus 5 to the power of a half. And here's the bit that is really essential. It's the function of x squared. The function of x squared. So here's the function of x squared dx. And now we have pi outside of from 0 to 3. Well, actually, using your index laws, this will be a half times 2, which is 1. So all we're doing is this. We're integrating x plus 5 dx. That's making use of our index laws. And that's an easy integration, that one. That's going to give us x squared on 2 plus 5x from 0 to 3. And pi, in our final line of working, this will be 9 on 2 plus 45. Oh, 45. I'm not good at maths. 9 on 2 plus 15 minus, well, when you put x equals 0 into all of these bits, then you just get 0. Not very interesting, is it? But it'll be 0 plus 0. So we'll have pi and 9 on 2, so that's 30 on 2. That'll be 39. Pi times 39 on 2, which may be in the textbook, it's 39 pi on 2 units. And the units for any volume are units cubed. For any area, it's going to be units squared. For any volume, it'll be the units cubed. 39 pi on 2 units cubed. Yeah, look, it says find the volume of the solid. It doesn't say to leave it in exact answer form, and it doesn't say to do it to any specific number of decimal places or any number of significant figures. So, for me, decimals are a thing of like, that's year 7 and 8 stuff. Decimals are general mathematics stuff. For you guys, pi should be there. You should always have pi in your answer if you can. Unless it specifically asks for it. But you should get comfortable with the idea of leaving symbolic or symbols in for the numbers. So 39 pi on 2 units cubed. And I don't mean to be snobby, that's just the fact that you need to get used to having pi in your answers and other symbols too. Probably the next most common one will be the letter E for the natural number, and you'll find out more about that in a little bit down the HSC course. Alright, so if it's around the x-axis, make it a function of x squared, have the limits, and then just do the integration. If it's around the y-axis, make sure it's a function of y squared with the limits, and then do the integration.